dear students, welcome to YourPedia. This is Chandrasekhar, faculty of Electrical and Electronics Engineering at YourPedia. We, YourPedia, started one question series for ISRO examination. Very good models of questions which are having more probability to reappear these models in upcoming ISRO examination for electronics engineering, right? So I am picking up two subjects, control systems and networks. So on weekly basis I am going to discuss 15 very good questions and I will be explaining you the concept also along with the question for this ISRO examination. So all of you listen to this particular video and you will get how to solve a problem. Very good models I am going to solve. Let's enter into the question series. 15 questions on each subject, control systems and networks. On weekly basis on both subjects, two videos you will be getting on YouTube from YourPedia. So these are the good questions having probability to get reappear in ISRO examination, right? Or at least the concepts are going to be useful for you if you learn for this ISRO examination. Yeah, let's enter into the question. Yeah, the question is consider the linear system x dot is equal to -1 0 0 -2 x with initial condition x of 0 is equal to 1 1. The solution of x of t for the system is, he is asking the solution of state equation, right? Solution of state equation he is asking. Yeah, a state equation is going to have two solutions. One is zero input solution. If input is 0, then who is going to provide output, initial condition. Another one is zero state response or zero state response, right? Means that is because of input. Zero state response means no state, means no previous value, no initial value, only because of input that response is considered. See, total response is equal to, see, a solution of state equation, x of t is equal to 0 input response plus 0 state response. 0 input response means this is because of only initial conditions, this is because of only input. Now in this question, input not given, therefore I have to find only 0 input response. So x of t is equal to 0 input response, that is equal to e power at into x of 0, where e power at is called as state transition matrix, state transition matrix, in bracket STM it is, yes, state transition matrix. Yeah, come on, STM, state transition matrix. So that is represented as phi of t. State transition matrix is equal to, yes, STM is equal to e power at, that is equal to Laplace inverse of Si minus a whole inverse. Laplace inverse of Si minus a whole inverse. What is the matrix A given by him? Matrix A given by him is -1 0 0 -2. Yes, that is -1 0 0 -2. Then how to get e power at? E power at is equal to Si, S0 0 S, I is identity matrix, minus A, -1 0 0 -2. If you do this, L inverse of this whole inverse, in fact this is, right? Now if I do this, I am going to get first one is S plus 1, this is 0, this is 0, this is S plus 2 whole inverse. Now for this one, Laplace inverse. Now come here. So Si minus a whole inverse, what is the matrix we are going to get? We have S plus 1 0 0 S plus 2. How to find its inverse Laplace transform? Not inverse Laplace transform, how to find its inverse of the matrix? That is 1 by AD minus BC, 1 by S plus 1 into S plus 2. Yeah, this is S plus 2, this is 0, this is 0, this is S plus 1, 2 by 2 matrix, 1 by AD minus BC. Exchange the positions of A and D and change the sign of B and C. So minus 0 will be again 0 0 only. Yes, then we are going to get it as Si minus A whole inverse is equal to 1 by S plus 1, 0, 0, 1 by S plus 2. This is Si minus A whole inverse. Then phi of t is equal to e power at is equal to inverse Laplace of yes, this Si minus A whole inverse. If you apply inverse Laplace transform, you are going to get it as 1 by S plus 1 e power minus t, 0, 0, e power minus 2t, e power minus 2t. Now observe, I am going to write the answer. I am going to write the answer. Observe here. This is the answer. So x of t is equal to e power at. Yes, how much you got? E power minus t, 0, 0, e power minus 2t. X of 0, yes, how much is x of 0? X of 0 is 1, 1. Yeah, x of 0. Initial conditions are the matrix 1 and 1. Yes, it is. Yes, come on. It is 1, 1. If you solve it, you are going to get it as x of t is equal to e power minus t, e power minus 2t. That much simple it is. That much simple it is. As the ISRO is not allowing calculator, therefore not calculator is not allowed. Most of the questions will be conceptual oriented than calculation oriented. Okay. Yeah. Then if you observe which option is going to be correctly suitable. Yeah, in fact it did not completely did not done the multiplication. So the last option D, you see e power minus t, 0, 0, e power minus 2t, 1, 1 is the perfect option for the given question, right? See, the question is very simple. If you know the formula, x of t, 0 input response is equal to e power at into x of 0, where e power at is equal to L inverse of Si minus A whole inverse, right? Yeah, let's go to the next question. What is this next question? So this question is very easy, though it looks very difficult. Some people will feel that, sir, I have to sketch Nyquist plot and all. Not required. Very easily I will tell you how to solve this question. Read the question first. The Nyquist plot of the transfer function g of s is equal to k by s square plus 2s plus 2 into s plus 2 does not encircle the point minus 1 plus j0 for k equal to 10. He is saying that the Nyquist plot is not going to encircle the critical point minus 1 comma j0 for k equal to 10. So n is equal to 0, that is equal to p minus z for what? K equal to 10. He is saying that for k equal to 10, this is the data what he given. In Nyquist stability criteria, n is equal to p minus z, where n is number of encirclements with respect to the critical point minus 1 comma j0. P is the number of open loop poles which are in the right half of S plane. I repeat, P is number of open loop poles which are in the right half of S plane. Z is the number of closed loop poles which are in the right half of S plane. Z is the number of closed loop poles in the right half of S plane. Yes, now if you see, P is equal to how much? 0. Number of open loop poles which are in the right half of S plane are 0. Observe that open loop transfer function. This is our open loop transfer function. How many poles it is having the right half of S plane? 0. No pole. See, both the poles, total 3 poles are there. All 3 poles are there in the left half of S plane. Open loop poles. P is number of open loop poles which are in right half of S plane. I repeat again and again. So 0 is equal to 0 minus z. That implies z is equal to 0. What is z? I told you that it is the number of closed loop poles which are in right half of S plane. P is equal to number of open loop poles in right half plane, and z is equal to number of closed loop poles in where? In right half plane. Yes. Now z is equal to how much I got? 0. Z is equal to 0 means the number of closed loop poles in right half plane is equal to 0. Therefore, for k equal to 10, system is stable. Therefore, for k equal to 10, system is said to be stable. System is said to be stable. Now let's read further. What is saying? Yeah, but does encircle the point minus 1 plus j0 for k equal to 100, then the closed loop system having the unity gain feedback is, he is saying that for k equal to 100 it is encircling, but how many times it is encircling he did not given, but n is not equal to 0. For k equal to 100, this is the data given by him. For k equal to 100, n is not equal to 0. N is a real number, real, I can say like integer, it's not any decimal point like 1.2, 1.3. N is number of encirclements. How many times the critical point -1 comma j0 is encircled by the Nyquist plot is n. If the encirclements are in anti-clockwise, n is positive. If the encirclements are in clockwise, n is said to be negative. Okay. Now n is not equal to 0. It may be positive or negative. I don't. He did not given, but n is not equal to 0. It is some number. So n is equal to what, ma? P minus z. But P is equal to what? P is the number of open loop poles which are in right half phase when P is equal to 0. Yeah, by looking at the open loop transfer function g of s, that is k by s square plus 2s plus 2 into s plus 2, number of poles which are, number of open loop poles which are in the right half phase plane are 0. So therefore, yes, n which is not equal to 0 equal to 0 minus z. Therefore, z is not equal to 0. Therefore, system is unstable. Why system is unstable, boss? System is unstable. Why? Because system is unstable. Why? Because there are some closed loop poles which in the right half of phase plane. Z is not equal to 0 means what? What is Z? Z is the number of closed loop poles which are in the right half of phase plane. Therefore, system is said to be what? Unstable. So which option is correct? See, stable for k equal to 10 and unstable for k equal to 100. Option B suits very well. For the previous question also, let me tick the option. Yeah, I already ticked it. Yes, option B is very much correct for the given question, right? Let's go to the next question. Next question. Yes. Yeah, this question directly we can answer. There are some formulae. I'll take up those formulas also. Yeah, read the question carefully. What he is saying is, for the given phase lead, it is phase lead network. So this is not load, that is a lead, L-E-A-D, phase lead network. The maximum phase lead is dash degrees. He is asking about maximum phase lead. First of all, this is a phase lead network. Yes, it is a phase lead network. This is a standard phase lead network. So we have the formula: maximum phase angle phi m is equal to solution. Maximum phase angle phi m is equal to sine inverse of 1 minus alpha by 1 plus alpha, where alpha is equal to R2 by R1 plus R2. Alpha is equal to, how much is R2? R2 is equal to 0.5. Let's take it as 1 by 2 only. 1 by 2 kilo ohms. Yes, and R1 is equal to 1 by 2 ohms only, not kilo ohms, please. My mistake. It is 1 by 2 ohms, not kilo ohms. Yeah, 1 by 2 ohm. R1 is equal to 1 ohm. Now alpha is equal to 1 by 2 by 1 plus 1 by 2. It is 1 by 2 by, yes, it is 3 by 2. This 2 gone. We are left with 1 by 3. Let's substitute. In the formula sine inverse of 1 minus alpha by 1 plus alpha. Therefore, phi m is equal to sine inverse of 1 minus 1 minus 1 by 3 by 1 plus 1 by 3. 1 plus 1 by 3. So phi m is equal to sine inverse of, come on, how much it is? 1 minus 1 by 3, 2 by 3 by 4 by 3. Yeah, this is equal to, phi m is equal to sine inverse of 1 by 2, that is equal to 30 degrees. The maximum phase angle this phase lead circuit can provide us is how much? 30 degrees. The answer is how many degrees, ma? Answer is 30 degrees. I'll write here. Answer is how much, ma? Answer is 30 degrees. See, you can download this questions as well as answers from our website, YourPedia website. Okay, all these are available, soft copies are available, you can download. Yeah, let's read the next question. This is also from state variable analysis. See, the topics of state variable analysis, especially controllers, compensators, these are very important in ISRO examination if you see the previous papers. Okay, yeah, read the question. Consider a state variable model of a system x1 dot x2 dot 0 1 minus alpha minus 2 beta x1 x2 0 alpha u. Okay, the damping ratio zeta and the undamped natural frequency omega n of the system are given by, he given state variable representation. He is asking us to find damping ratio zeta and undamped natural frequency omega n. Okay, yeah. Now, first of all, if I want to find zeta, definitely I need characteristic equation. What is a characteristic equation? What is a characteristic equation from state variable representation? Characteristic equation is equal to det of Si minus A is equal to 0, where S is a Laplace operator, I is a unity matrix, I is 1001, A is a matrix A. This is matrix A. See, this is matrix A. What is the general representation? Standard representation of state variable is x dot is equal to Ax plus Bu. This U is not unit step, that is some input matrix. Yes, input matrix. See, if you talk about the sizes of the matrices, if my system is of nth order, then how many states it is going to have? N states it is going to have. Therefore, x1, x2, x3 and so on, xn, n by 1. If my system is having p inputs, it will be p by 1. This size will be p by 1. Now, if it is having n states, then derivatives also n will exist, it is n by 1. Then let's understand about the size of this matrix A. For this multiplication to possible, it should be n by n. For this multiplication and addition to be possible, this should be n by p, right? This easily we can understand. There may be a question on the size of the matrices, or some options you can directly eliminate in some question by looking at the size of the matrices, right? Yeah, let's come here. Now, characteristic equation is equal to det of S0, 0S, yes, minus, what is matrix A? 0, 1, minus alpha, minus 2 beta, right, is equal to 0. Therefore, characteristic equation is equal to S, this is minus 1, this is plus alpha, this is S plus 2 beta, S plus 2 beta is equal to 0, right? S plus 2 beta equal to 0, yeah, S minus 1 alpha, yeah, S minus 1 alpha, S plus 2 beta is equal to 0. Now, if you do it, S into S plus 2 beta minus of minus plus alpha is equal to 0. So, S square plus S into 2 beta plus alpha is equal to 0. Now, he is asking us to find what is zeta, damping ratio, and undamped natural frequency omega n. If you compare this one with our standard equation, standard second order characteristic equation, underdamped in fact, 2 zeta omega ns need not to be underdamped, okay, need not to be underdamped. This is our standard equation. If you compare simply, omega n square is equal to alpha, so omega n is equal to under root of alpha. In the same way, 2 beta is equal to 2 zeta omega n. So 2 gone. So beta is equal to zeta is already, zeta I have to find, sorry, I have to find zeta I have to find, omega n is root alpha. So damping ratio zeta is equal to beta by root alpha. Let's see which option is going to suit. Which option is going to suit? Beta by root alpha and root alpha. Yes, beta by root alpha and root alpha. You see, option A suits very well for the given question. The only thing you have to remember is characteristic equation is delta of Si minus A is equal to 0, and the standard characteristic equation of a second order system is S square plus 2 zeta omega n s plus omega n square is equal to 0. You have to compare, right? Let's go to the next question. Yeah, this question is given, it's a good question in fact, but very simply you are going to solve. The Bode magnitude plot of a phase lead network is shown below. Determine R1 and R2 in kilo ohms. He is asking us to find R1 and R2 in kilo ohms. What is the standard transfer function of this phase lead compensator? The phase lead compensator standard transfer function is V naught of S by Vi of S is equal to S plus 1 by tau by S plus 1 by alpha tau, right, where S is equal to minus 1 by tau is a 0, and S is equal to minus 1 by alpha tau is a pole, right? At a 0, the slope of Bode magnitude plot, with the introduction of 0, the slope of Bode magnitude plot will rise by plus 20 dB per decade. With the introduction of a pole, the slope of Bode magnitude plot will decrease by 20 dB per decade, or the slope of the Bode magnitude plot will get added with minus 20 dB per decade. This way we can understand. So we all know one point that these poles and zeros are called as corner frequencies. What is the first corner frequency he mentioned? Yeah, this is the first corner frequency. If you observe till here, the Bode magnitude plot is having a slope of 0, but all of a sudden, yes, the slope is raised. That's why value is rising, you see. The slope is raised. But here, again the slope became 0, means here a 0 is added, here a pole is added. That way we have to understand. This is the first corner frequency omega C1. This is second corner frequency omega C2. At the first corner frequency omega C1, I have a 0. Yeah, what is that? Let's solve it. Very good question it is. Very good question. There is a possibility for this set of questions to be asked in the examination. Omega C1 is equal to 1 by tau is equal to 1 into 10 to the power of minus 3. Omega C2 is equal to 1 by alpha tau is equal to 2 into 10 to the power of minus 3, right? Am I right? Let's check. 2 into 10 to the power of minus 3. Now, what is tau? Tau is equal to R1C, and what is alpha? Alpha is equal to R2 by R1 plus R2. Yes. Now you know what does it mean by alpha tau also. So from this one I will get R1C is equal to 1000. This is equation 1. I keep it like this. Let's see what is the data given. He is asking us to find the values of R1 and R2. Yeah. R1 into, what is the C value given? 1 microfarad. 1 microfarad is equal to 1000. So R1 is equal to 1000 divided by 1 microfarad. It is going to give, 1 gigaohms. 10 to the power of 6 into 10 to the power of 3 will be 1 into 10 to the power of 9 ohms. R1 is 1 into 10 to the power of 9 ohms. Yes. So he is asking us in kilo ohms. But whereas the options are not matching, it seems. Capacitance is given in microfarads. So this is omega C1. This is the frequency. Omega C1 is equal to 1 by tau. 1 by tau is equal to, okay, sorry, I took it in wrong way. This is 1 by 10 to the power of minus 3. I taken it wrong. Please observe. This is not 1 into, yeah, that's why options are not matching. Yeah, what is this? 1 by, this is 2 by, right? Now from here everything I have to redo, right? I am doing it again. Now observe here, from this one tau is equal to, tau is equal to 10 to the power of minus 3, but tau is equal to what, ma? R1C. C is equal to 1 into 10 to the power of minus 6 farad, C given 1 micro. Therefore, R1 is equal to 10 to the power of minus 3 by 10 to the power of minus 6. This is going to be 10 cube ohms. Therefore, R1 is equal to simply 1 kilo ohm. We got R1. Let's find R2. For finding R2, simply what is omega C2? 2 by 10 to the power of minus 3 is equal to 1 by, sorry, not 1 by, 2 by, sorry, 1 by alpha is R2 by R1 plus R2 into tau. How much is tau? Tau is 10 to the power of minus 3. This is 10 to the power of minus 3. This 10 to the power of minus 3, this 10 to the power of minus 3 gone. Now, what we are going to have? That 10 to the power of minus 3 gone. Come here. 2 is equal to 1 by R2 by R1 plus R2. Therefore, I can write R2 by R1 plus R2 is equal to 1 by 2. Therefore, 2R2 is equal to R1 plus R2. Here, R2 is equal to simply, our calculation is correct only, na? 2R2 is equal to R1 plus R2. Therefore, R2 is equal to R1. Both are same 1 kilo ohms. Choice is yes. Which option is correct? Go back. Which option is correct? Both 1 and 1. I think option is not there, but both are 1 and 1 only. Both are 1 and 1. I think we did not commit any mistake. Both are 1 and 1. Let's change this one as 1 and 1. Both are 1 kilo ohm and 1 kilo ohm. That's all. But see, here the procedure is very important. Formulas. Okay, procedure and formulas are very important. See, 1 by alpha tau, where alpha is equal to R2 by R1 plus R2. R2 by R1 plus R2, and alpha is less than 1 always. Alpha is less than 1. So, R2 by R1 plus R. So, any mistake I committed here in this calculation, let's check. 10 to the power of minus 3, 10 to the power of minus 3 gone. I am taking reciprocal of this one. If I take the reciprocal of this one, R2 by R1 plus R2 only, perfect it is, no issues. Okay. Let's go to the next question. This question is a basic question from block diagram reduction techniques. Many people will apply block diagram reduction rules, or you can apply directly Masson's gain formula also for this question. See, if a question is very big, it is having lots of calculations in block diagram, directly you can apply Masson's gain formula. Masson's gain formula is equally applicable for block diagrams also. People will convert the block diagram to signal flow graph, then they will apply Masson's gain formula, but that much not required, that much struggle not required. Directly you can apply Masson's gain formula for this block diagrams also. Observe here, what is asking? Transfer function, output by input, C of S by R of S is equal to, what is the formula? Masson's gain formula, M1 delta 1 plus M2 delta 2 and so on by delta, where M1, M2, M3 are forward path gains. Yes. How many forward paths are there from input to output? See, this is one way, this is one forward path. Second forward path is this one, right? Is there any other forward path? There is no scope of any other forward path. Only two forward paths. What are the forward path gains? I am taking M1 is first forward path gain. What it is? 1 by S, 1 by S, 1 by S square. M1 is 1 by S square. M2 second forward path gain. Second forward path gain is yes this way. Simply this is plus 1. It is not having, yes, it is not having, I can say, any S values, therefore directly it is 1. Right? What is delta? Delta is equal to 1 minus sum of all the individual loop gains. How to form a loop in this block diagrams? To form a loop, you have to start at a summing point and end at the same summing point. You see, this forms a loop. This forms a loop. This is the first loop I can take. How much is the loop gain? Minus of 1 by S. Minus of 1 by S. This is a second loop. Yes, this forms a loop. That is second loop. Minus of 1 by S. Minus of 1 by S. That is second loop. Let's see possibility of any other loop. So people will think that yes sir, this will be a loop. No, because I have to travel here opposite to the arrow direction. And any other possibility this way? No, not possible. Any possibility of this way? Yes, I'll show you what is that way. I'll show you what is that way. I'll write it. Yeah, minus 1 by s minus 1 by s. Observe and tell me whether this loop is possible or not. Not possible. Not possible. Because I have to travel the opposite direction to the arrow. I have to travel opposite direction to the arrow. Any other possibility? Any other possibility? No. Only two loops. Only two loops. Tell me, both the loops are touching or non-touching or non-touching? How can you say that both the loops are non-touching? You see, this is the ending of the first loop. This is the starting of the second loop. If takeoff point is before summing point, then both the loops are said to be non-touching in block diagrams. If takeoff point is there after summing point in block diagrams, then both the loops are said to be touching. Both are non-touching here. Now, what is the delta formula? 1 minus sum of all individual loop gains plus product of two non-touching loop pairs minus product of three non-touching loop pairs, sum of product of three non-touching loop pairs and all, right? So it is minus 1 by s into minus 1 by s is 1 by s square, right? So delta is equal to 1 plus 2 by s plus 1 by s square. Now delta 1 minus, what is the first forward path I taken? To this forward path all loops are touching, to that forward path all loops are touching. Delta 1 is 1, yes. What is delta 2? Delta 2 is also 1, delta 2 is also 1. Why? Because this is the second forward path. To this forward path, yeah, delta 2 is not 1, yes. This particular loop is non-touching to the second forward path, right? It is non-touching. Therefore, delta 2 is equal to 1 minus sum of all individual loop gains. So it is how much? 1 plus 1 by s. Let me write this formula clearly, this substitution very clearly. Yes, C of s by r of s, C of s by r of s is equal to m1 is 1 by s square, delta 1 is 1 plus m2 is 1 into 1 plus 1 by s by 1 plus, yes, 2 by s plus 1 by s square. If I simplify it, C of s by r of s is equal to 1 by s square plus 1 plus 1 by s by s square plus 2s plus 1 by s square. So that is equal to, if I write here, s square plus s plus 1 by s square plus 2s plus 1. Check it. S square plus s plus 1 by s square plus 2s plus 1. Very good question. We will get confused. What are the points we get confused? This delta 2, in fact, delta 1, delta 2 are very important 2 points. And counting number of loops, number of non-touching loop, number of forward paths. These are the confusing areas in this particular problem. Okay, let's go to the next question. Yeah, this question directly we will solve. Okay, it looks very big, but I'll give you one shortcut formula. Select the correct transfer function V0 of s by V of s from the following for the given system. Now here R, L, R, C connected. See, this is the first circuit connected in cascade with the second circuit. Even in fact that is also not required for us here. So my point here is solution. Yes, if I have impedances Z1, Z2, Z3 and Z4 like this in cascade, like this, in this way are there. Okay, this is input voltage VA of s, this is output voltage V0 of s. For this one, direct formula for V0 of s by VA of s is V0 of s by VA of s is equal to Z2 Z4 by Z1 into Z2 plus Z3 plus Z4 plus yes Z2 into Z3 plus Z4, right? Z4 it is, let me write it clearly, Z4, clear? Just substitution. In place of Z1 1 ohm, Z2 S ohms, Z3 1 ohm, Z4 1 by S ohms, S and 1 by S are in ohms. Okay, let's substitute, okay, that is the formula. You can easily remember 2 4 by 1 2 3 4 2 3 4, 2 4 product of shunt elements by start with 1 into 2 plus 3 plus 4 plus start with 2 into 3 plus 4, that way you can remember. So 1 S 1 by S, see V naught of S pi Vi of S is equal to 1 S 1 by S plus Z2 Z3 Z4 2, this is Z2 Z3 Z4 S into 1 by S. So V naught of S by Vi of S is equal to 1 by S plus 1 plus 1 by S plus S plus 1. So if you simplify it, 1 by S plus 2S plus 2, that is equal to 2S square plus 2S plus 1. In the numerator you are going to get it as S. S by 2S square plus 2S plus 1. S by 2S square plus 2S plus 1. Choice is C. Choice C. Option C is the perfect answer. Let's go to the next question. Next question. This question is very simple one. Okay. Consider a control system shown in figure. For a slight variation in G, the ratio of is asking the ratio of open loop transfer function G of S into H of S to closed loop the ratio of open loop sensitivity to the closed loop sensitivity will be, question looks simple, but it is okay, it is having good stuff to understand. So he is asking, read the question again. Consider a control system shown in figure for a slight variation in G. So he is taking the variation in G, the ratio of open loop sensitivity to the closed loop sensitivity means sensitivity of OLTF, open loop transfer function, with respect to G, and we have to find, and sensitivity of closed loop transfer function with respect to G. These two things I have to find, and I have to take the ratio of these two things. Good question. Sensitivity of open loop transfer function with respect to variations in G, sensitivity of closed loop transfer function with respect to variations in G. Let's do it. If we find, I'll find one by one. Okay, observe it carefully. Sensitivity of OLTF is what? GH with respect to G. Yes. What is the formula? See, I'll write this way. Sensitivity of M, any transfer function M with respect to G is equal to dou M by dou G by G. That is dou M by dou G into G by M. That is equal to dou by dou G into M is what? M is GH here. For OLTF we are finding M is GH. Open loop transfer function is G into H into G by M is GH. Right? This G gone. Sensitivity of GH with respect to G will be H into 1 by H, that is equal to 1. Sensitivity of open loop transfer function with respect to variations in G is equal to 1. Next, sensitivity of M, here M is G by 1 plus GH, closed loop transfer function with respect to G is equal to, dou m by dou g into g by m, dou by dou g into m is what? G by 1 plus gh into g by m is g by 1 plus gh, right? Now sensitivity of m with respect to g is equal to, this g gone, this is 1 plus gh into 1 minus g into 1 plus gh is h by 1 plus gh whole square into 1 by 1 plus gh. This 1 plus gh, this gone. So this gh gone. You will get this one as 1 by 1 plus gh. Yes, 1 by 1 plus gh. Observe it carefully here. Observe it carefully. So ratio of sensitivity of gh with respect to g by the ratio of sensitivity of g by 1 plus gh. G by 1 plus gh with respect to g. This is equal to 1 and this is equal to 1 by 1 plus gh, right? So this can be written as 1:1 plus gh inverse like this, right? Observe it. Which option is correct? Observe it. 1:1 plus gh whole inverse, right? Option B, choice B perfectly suits well. Choice B perfectly suits here. Choice is B, right? So this way we can do it very easily, right? But understanding the question is very important. Let's go to the next. This question is about finding C of S by R of S. One signal flow graph is given. See, here same Mason's gain formula, C by R is equal to, how many forward paths are there? I hope only one forward path. You can see only one forward path from R to C. Only one. There is no way to travel. What is the forward path gain? That is 1 by S into 1 into 1 by S into, in fact 1 into 1 by S into 1 by into delta 1. Delta 1 will be 1 only because there are how many loops? 1, 2, 3, 4 loops are there. First loop, second loop, third loop, fourth loop. There are 4 loops. All 4 loops into the forward path. Only one forward path is there. By delta is delta. Let's write delta separately. Delta is equal to 1 minus sum of all individual loop gains. First loop is minus 1. Second loop is minus 1 by S. Third loop is minus S. Fourth loop is minus 1. Plus product of two non-touching loop pairs. See, loop 1, I write here L1, this is L2, this is L3, this is L4. L1 with L3 is non-touching, L1 is minus 1, with L3 minus S is 1 pair, plus L1 with L4 is also non-touching. Check L1 with L2, L3, L4. Check L2 with L1, L2, L1, L3, L4. Check L3 with L1, L2, L4. Check L4 with L1, L2, L3. Then that will complete, right? L1 with L3 plus L1 with L4 minus 1 into minus 1, right? L1 is done. L1 with L2 is touching. L1 with L3 is non-touching, we taken it. L1 with L4 non-touching, we taken it. Then you start with L2. L2 with L1 is touching, no possibility. L2 with L3 is touching, no possibility. But L2 with L4 is going to form one pair. L2 is a minus 1 by S and L4 is minus 1. That is a possible combination. L2 with L4. L2 is done. So now start with L3. L3 with L1 already taken. Yes. L1 with L3 or L3 with L1 already taken. L3 with L2 is touching, L3 with L4 is touching. Leave L3. Take L4. L4 with L1 already taken. L4 with L2. L2 with L4. L2 with L4 already taken, L4 with L3 touching, therefore this is only, right, this is only, yeah, up to here only. Yeah, I will erase it, just give me a moment, I am going to erase it. Now 2 non-touching loop pairs are done. Is there any 3 non-touching loop pairs possible? 3 non-touching loop pairs. So if you take L1, L1, L4, both 2 are non-touching, with L2 touching, with L3 touching, L1, L2 not possible, 3 non-touching. Now plus 0. Now how much is delta? Delta is equal to 1 plus 1 plus 1 plus 1 plus 1 by s plus s plus 1 plus s plus 1 plus 1 by s. So delta is equal to 1 plus 1 2, 2 plus 1 1 plus 1 2, 2 plus 1 3, right, 3 plus 1 4, total 4 ones are there. Check my calculation, if there is any mistake in my calculation please let me know, right. Now s plus s, there is 2s, 1 by s plus 1 by s, there is 2 by s, right, 2 by s. So delta is equal to, let me simplify it, delta is equal to 2 by s plus 2s plus 4. So C by R is equal to M, that is 1. This S 1 by S gone, we are left with 1 by delta, yeah, 1 by S 2s square plus 4s plus 2, this s will come here, then C by R is equal to s by, if I take 2 common, s square plus 2s plus 1, that is equal to s by 2 into s plus 1 whole square. See, in this question there is no logic, but you have to do it carefully. If you miss even a simple calculation, your entire answer is going to be wrong, right? Option, yeah, s by 2 into s plus 1 whole square, choice D. Choice D suits very well for this question. Choice is D, right? Let's go to the next question. Yeah, this is also a good question. The unit impulse response of a unity feedback system is given by C of t is equal to t into e power minus t plus 2 into e power minus t. The open loop transfer function is equal to, from this one first of all, closed loop transfer function is equal to Laplace transform of impulse response. What is the Laplace transform of, in fact, unit impulse response? Laplace transform of what is the impulse response given? T into e power minus t plus 2 into e power minus t. So from this one, from here onwards solution starts. Okay, yeah, come here, what we are going to get? So CLTF is equal to, how much it is? 1 by s plus 1 whole square, 1 by s plus 1 whole square plus 2 by s plus 1, 2 by s plus 1, Laplace transform. See, e power minus t Laplace transform is 1 by s plus 1, as t is there, 1 by s plus 1 whole square, this is 2 by s plus 1. Now if I do it, closed loop transfer function is equal to, this will be s plus 1 whole square, right? Now 2 into s plus 1 plus 1, right? So closed loop transfer function is equal to 2s plus 3 by s plus 1 whole square. But he asked what? He asked open loop transfer function. Open loop transfer function. You know, OLTF is equal to CLTF by 1 minus CLTF for a unity negative feedback system, right? If you do this, you are going to get 2s plus 3 by, or I'll take in the next page, just leave this one here, CLTF, yeah, answer. So OLTF is equal to 2s plus 3 by s plus 1 whole square minus 2s minus 3. So OLTF is equal to 2s plus 3 by s square plus 2s plus 1 minus 2s minus 3. This plus 2s gone. So OLTF is equal to 2s plus 3 by s square minus 2. Let's see whether that is there in the options or not. No, it is not there in the options. So we committed some mistake at somewhere. We have to check what is that. We might committed some calculation mistake. Yeah. So the unit impulse response of a unit negative feedback system is given by t into e power minus t into 2 into e power minus t. Okay. This is 1 by s plus 1 whole square, 2 by s plus 1. Okay, fine. Does this calculation is correct or not? Okay. 1 by s plus 2 by s plus 1 plus 1 by s plus 1 whole square. So CLTF is equal to 2s plus 2 plus 1. So 2s plus 3 by s plus 1 whole square. Fine. This is OLTF. So let's do here again the simplification. Let's do this simplification again. I'm going to do it again. Observe. Yeah. So OLTF is equal to CLTF by 1 minus CLTF, right? What is CLTF? 2s plus 3 by s plus 1 whole square by 1 minus 2s plus 3 by s plus 1 whole square. If you do this, you are going to get it as 2s plus 3 by s plus 1 whole square minus of 2s plus 3 only. There may be, I think we did not commit any calculation mistake. Yes, we did not commit any calculation mistake. 2s plus 3 by s square, yes, plus 2s plus 1 a plus b whole square minus 2s minus 3. This 2s gone. So what we got here is OLTF is equal to 2s plus 3 by s square minus 2. But in the option not there. 2s plus 3 by s square. 1 minus 3 will be minus 2 only. Let's see what happened here. Maybe some mistake in the question which is not matching with the answers, right? See, closed loop transfer function is equal to Laplace transform of unit impulse response. This is very clear. If you apply, because I'll prove here. Transfer function is equal to Laplace transform of output by Laplace transform of input. If your input is unit impulse, means 1 into del of t. So what is the Laplace transform of 1 into del of t is 1. Therefore transfer function is equal to Laplace transform of simply c of t. This response is called as unit impulse response. That's what. Okay. Anyhow, with options it is not matching, but the procedure is this one only. Do remember. Okay. Yeah. Let's go to the next question. Yeah. This is also one of the very good question. Consider a second order system with a transfer function g of s is equal to, this transfer function means it is a closed loop transfer function. Why? Because it did not mention it as open loop. If it is open loop transfer function, that fellow will clearly mention it as open loop transfer function, right? 1 by s square plus 2s plus 1 with a unit step input 1 by s as an input. Let c of s be the system corresponding output. The time taken by the system c of t to reach 95% of its steady state value. Yeah. The time taken to reach 95% of its steady state value. See, what is the damping of the system? Damping zeta is equal to how much it is? 1. Yeah, it is 2 poles are real and equal, therefore it is a critically damped system. The time taken by that response to reach 95% of its final value for a critical damped system is similar to that of first order system. It is how much percentage is asking? 95%. It is 3 tau, where tau is equal to, tell me, tau is equal to 1 by zeta omega n, or very simply it is the reciprocal of the magnitude of the pole. Yes, it is 1 second simply. Therefore time taken to reach 95%, time taken to reach 95% of final value is equal to 3 tau, that is equal to 3 seconds. That is equal to 3 seconds. Option D. Option is D. Let's go to the next question. This is also very easy question. He is asking us to find the output by input y of s by r of s. Y of s by r of s. How many forward paths? I told you already. You can directly apply formula. Here you can find a good number of forward paths. I can say like you can find here 2 forward paths. This is one is with this with this s, another one is with down 1 by s. There are 2 forward paths. First forward path is s into 1 by s is 1 into delta 1, plus second forward path is s 1 by s into 1 by s, 1 by s square into delta 2 by delta. But for finding delta is equal to 1 minus loops. Carefully we have to calculate loops. Observe all of you here. Whether these are correct or not, just let me know. I am starting at this. Yeah, this is one loop or not? Yes, obviously that is a loop. What is that value? S plus 1 plus 1 s plus 1 minus 1, that is minus s in fact. Yeah, that is done minus s, sum of all the individual loop gains. Second loop is does this is not a loop? This is also will be a loop. That is also will be a loop. 1 by s minus 1 by s in fact. Minus 1 by s is a loop. Minus of 1 by s is a loop. Second loop. Third loop, is it not a third loop? Yes, that is possible. That is third loop. That is possible. How much it is? Minus 1 by s. This is plus here, please. This is plus here, not multiplication. Plus minus of 1 by s. Third loop. Fourth, does this is not a loop? Yes, this is also a loop. That is also a loop. Right? That is also a loop. How much is the value? 1 by s minus, therefore it is minus 1 by s square minus of 1 by s square. Again, we taken upside, we taken this downside. Now, is this is not a loop, or did we taken this one? 1 by s minus 1 by s, we taken it. Minus s minus 1 by s. After that, minus 1 by s minus 1 by s square. I think no more loops are possible. No more loops are possible. These are the total loops. Plus product of 2 non-touching loops. Is there any loop which is non-touching? All the loops are touching with each other. That will be 0. Now delta 1 is equal to delta 1. See, to the first forward path, I have only one forward path. To this forward path, all the loops are touching. Delta 1 is also 1. You can solve it. You are going to get the correct answer. Just substitution. But finding the number of loops and number of forward paths are there, it is very important. Okay. Let's go to the next question now. Yeah, this is a good question. Number of times in DRDO, ISRO, this has been asked. Okay. The second order system poles location in the S-plane are shown in shaded region. Okay. The region of damping ratio of the system is the range of, not region of, the range of damping ratio of the system is. He is asking about the damping ratio of zeta. Okay. Observe here carefully. See, observe it carefully. See, this is 30, right? This is 30. This total, see, I can say like, this is 30, this is 30. This fellow mentioned this one as 60, this one as 60, right? No, that is not 60. If that is 60, 30 plus 60 will be 90, then it should be here. No. Yeah. What he mentioning here is, this total is 120. This is 60 plus 60, the total is 120, right? Total is 120. Therefore, this total is 60. This is 30, therefore this particular part is also 30. This particular part is also 30. Means this is 30, this is 60. Clearly mentioned, this is 30, this is 60. Therefore, this is 30 and this particular part is 60. So, the poles are there in this region, in the shaded region. Means in between the angle 30 and 60. What is damping ratio zeta? Zeta is equal to cos theta. So, cos theta, zeta 1 is cos 30. Cos 30 is root 3 by 2. Another zeta 2 is equal to cos theta is equal to cos 60, that is equal to 1 by 2. The damping ratio is going to vary in between 0.5 to 0.866. 0.5 to 0.866. Somewhat the diagram looks confusing, but you have to look carefully. If you look carefully, then you are going to get the perfect answer. Let's go to the next question. This question is a very good question, number of times previously asked. In ISRO examination asked, in DRDO asked, in GATE examination asked, in engineering service examination many times this question was asked. Okay, he's saying for the system shown in figure with a damping ratio of 0.7, what is saying? Zeta is equal to 0.7. Okay, zeta is equal to 0.7 and undamped natural frequency means omega n is equal to 4 radians per second. 4 radians per second. Okay, the values of k and a are, what is the characteristic equation? Characteristic equation is equal to 1 plus k into 1 plus as by, just let me write, 1 plus as by s square plus 2s is equal to 0. So, characteristic equation is equal to s square plus 2s plus aks plus k equal to 0, right? Then he is asking the values of k and a. Here something we have to very clearly we have to think while doing calculation. So, s square plus take s common, what is that? 2 plus ak plus k is equal to 0. Omega n square is equal to k. Omega n square is equal to k. That implies k is equal to omega n square. How much it is? 16. K equal to 16. K equal to 16. The only one option having k equal to 16 is option C. Therefore, you can directly tick for it. You need not to do for A. Suppose if k is matching in more than one option, you have to go for the calculation of A also. But here also calculating this A is easy. How to do it? 2 into zeta 0.7 into omega n is 4 is equal to 2 plus A into 16. You solve that A, you are going to get the value of A. You are going to get the value of K, right? Let's go to the next question. A system block diagram is shown in figure. He is asking the overall transfer function of the system is C by R is equal to something he given. He is asking what should be the value of this X. I will give you the hint how to solve it, you do it. Simple question only. Find its transfer function. What is its transfer function? How to find? Apply Mason's gain formula. Get one transfer function. Make that transfer function equal to this value, then you are going to get the value of X. That's all. There's no big deal in it, just a calculation. Why? Because why I am giving this one as a work for you, because this type of questions 2 to 3 we solved already, right? There is no big deal in it. Find that transfer function in terms of X you get, compare that one with this one, then you are going to get the answer X, right? So this way we are going to solve, many questions on control systems which are having probability to be asked in your upcoming ISRO examination. With concepts we are going to learn the problems. Thank you.